Welcome everybody. In this video we'll look at the properties of repeating decimals, and repeating decimals should be quite familiar to everybody because repeating decimal can be something like that. So the same pattern keeps repeating itself infinitely. The pattern here is 1, 2, 3 for this problem. Or the other thing may be something like, maybe first of all it doesn't really repeat itself, but ultimately you'll see the pattern like that. So now in that case the repeating pattern is a single number 7. So in general it's pretty interesting to see such a pattern that keeps repeating itself infinitely. And just to simplify the notations a little bit, from now on we'll use the following notation to repeat the to write down the repeating pattern. For example, now in this case the repeating pattern is 1, 2, 3. So we try to add a bar on top of the repeating pattern here. And for this second example here, for the numbers that are not repeating, there should not be any bar on top of that. And now this case is that the repeating number is really just the one single number. So you just have to put one bar on top of the repeating pattern, which is the single number 7 here. So now in this video we'll follow these two kind of notations, and now the goal is that I want to express all repeating decimals as fractions, and actually it's always possible to do it, and this video will try to look at the way to do it. Please look at the following example first. So now I take the simple example 0.33333 and so on. So now the repeating pattern is really just one single number 3 here. And the way to do it is, the first step, you need to let x be the number I'm talking about, which is 0.33333 and so on. And then the next step, please try the following artificial step, that you multiply both equations, both sides of the equation by 10. So what happens to this number? 10 times x is the same as 10 times the repeating pattern 0.33 and so on. And this number becomes 3.3333 and so on. So the repeating pattern is the same after the dot. The only change is that now the integral part becomes 3 here. So anyway, now we have got two equations here, and I ask you to do one clever trick here. You have to subtract the first equation from the second one to see what happens. Now 10x minus x becomes 3.3 repeating pattern minus 0.3, which is repeating again. So amazingly speaking, maybe some of you have noticed already the right side what's happening. We don't have the infinite pattern anymore because these two parts are cancelled out. So now the right side, you arrive at 3 only, and definitely the left side becomes 9x. Obviously, you know how to solve this equation. X is just 1 over 3, which means that we have the following equation, that 1 over 3 is exactly the same as the repeating pattern we are talking about at the beginning. So it's pretty interesting, right? So let's look at some more complicated example from now on. The second example of today is the following. Please look at these repeating decimals here, 0.123, 123, 123 and so on indefinitely. So now please follow the previous method, that you have to let x to be the number I'm talking about. So the ultimate goal is that you need to write down x as a fraction. So the point is how to do it. And if you follow the previous method to multiply x by 10, you're not going to get anything very interesting and decisive for our answer here, because if you multiply by 10 you couldn't really cancel out the repeating pattern after the decimals. So now in this case, because the repeating pattern contains 3 numbers, what you need to do is you have to multiply by 1000x. Just see what happens if you multiply by 1000x. Can somebody tell me here? It becomes the following number, 123 times 123 repeating pattern. It's pretty amazing, because now in this case, if you look at these two equations, they have the same repeating pattern after the decimals, and definitely you know how to cancel it out. So okay, you subtract the first equation from the second one. So 1000x minus x equals this number minus this number, and the repeating pattern is amazingly cancelled out. So you're left with 1, 2, 3 here. And I believe you know how to solve this equation. It becomes 1, 2, 3 over 999. And that's exactly what I want here. that you're able to arrive at the following thing, that this repeating pattern 0.123, and so on is equal to the fraction 123 over 999. I don't think it's a trivial and obvious result without this method here. Okay, so let's try another example which is even more complicated. Please look at this complicated repeating pattern. The repeating pattern, please note that it doesn't really start exactly right after the dot. It starts a little bit later. The repeating pattern now is 78 here. And please follow the previous way of working. You let x equals the number I'm talking about. And ultimately, I want you to derive the fraction of x here. And the point is that, just like the previous two examples, you need to cancel out the repeating pattern somehow by multiplying x by a certain number that is multiple of 10, 100, etc. So please try your luck here. I believe we can try 100x because of the fact that the repeating pattern has two numbers only. So now the right side becomes 741.787878 and so on. Essentially speaking, the repeating pattern now starts exactly right after the dot, but in this case we can just look at this repeating pattern starting from here, because if you look at it this way, if you subtract the second equation from the first one, so it's like second equation minus the first one, you should be able to cancel out the repeating pattern here, right? So please let me know the answer here. 100x minus x becomes 741.7878 minus 7.4178, and the repeating pattern has the same location, which means we can cancel it out to get the following number. To get this number is the same as 99/8. So now please let me know how to do the following. Now x becomes the fraction 734.37 over 99, and definitely it's almost close to our final answer. You just have to multiply both sides so that the numerator shouldn't be anything like decimals, so which means we're able to multiply the two sides by 100 to get the following number. So please verify by calculator that we are able to arrive at the following. So please check by calculator to see what happens to this fraction. You should be able to arrive at this repeating pattern here. So I think it's a pretty amazing method because it's totally non-trivial why such a big fraction is the same as a repeating decimal like that. But in general, this method always works for all kind of repeating decimals. So just a note for all of you here. You should be able to get the answers to the following two questions. It's practice for you to get familiar with this amazing and interesting method. And that's the end of this video. Please try these two problems. Post the answers to the YouTube page of mine. And thank you everybody. See you next time.